Hi Professor Chen, this is my second video of HW10 and this video is about question 2. And the question is collect the definition of properties of different stochastic processes. And the first one is wild sense stationary process. In order to discuss this one, let's focus on the fixed one, strict sense stationary process. And we say a real statistic process xt is stationary in strict sense if its statistic is not affected by a shift on the time axis, which means the two process xt and xt plus epsilon have same statistic for any epsilon, but it's kind of a strict condition to meet. So we have a weakly stationary process here, which also referred as wild sense stationary process, and a statistic process with ext equal to a constant and rt1 t2 equal to r tau, where tau equal to t2 minus t1, and this process can be called as WSS process, which means the ext is equal to constant and the autocorrelation only depend on the difference between T1 and T2. And if a process can meet these two conditions here, this process can be called as WSS process. And the second one is independent increment process. We say that xt is the process with independent increment if the probability of xta minus xt2 less or equal to x1 and xtc minus xtd less or equal to xc2 equal to the probability of these two different circumstances for any non-overlapping intervals. We can say this process is an independent increment process. And based on the definition here, we can easily say that the Poisson process, random walk, and Wiener process are all independent increment process here. And the Markov process, we say that a process xt is a Markov process if the past has no influence on the statistic of the future under the condition that the present is known. And the Poisson process, a semi-random telegraph signal process, and the random walk process, all these processes are Markov process because the future statistic does not depend on the past. So all these are Markov process here. And fourth one is normal process. A process xt is said to be normal if the random variable xt1, xt2 to xtn are jointly normal for any n, and any t1, t2 to tn. And this is easy to understand. If xt1, xt2, xt2 meet this condition here, it can be viewed as normal process. And the sixth one is wild noise. Vt is the sixth one is the white noise. Vt is the white noise if the E Vt equal to 0 and the R T1 T2 equal to Qt1, then multiply the delta T1 minus T2, and where the Qt1 is called the average intensity. And we can see that the white noise is a process such that its value are at different times. For example, the XTI and XTJ are nearly independent, but actually they are uncorrelated. And the seventh one is a mean ergodic process. Xt is said to be a mean ergodic process if this part is equal to ext in mean square sense. And just like its name, mean ergodic process, we just need to make sure this part equal to this part in mean square sense. But based on the following questions, in order to determine if the if a process is a mean ergodic process, first we need to make sure this process is WSS. Then we discuss a necessary condition of its autocovariance to see if it is a mean ergodic process. That's all.